This video is going to talk about how to find the pivot, i.e. how to find a new or better solution given a current solution of your transportation problem. In other words, what's the new edge to add in to your solution? So first of all here, we're going to start from the point where you have an initial solution. In our case, we've done this in a previous video. So step 2. What we're going to do is we're going to calculate something called the selling price. Here, what we do is we do the following. This guy, U with a subscript I, is considered the price of your item at your warehouse. So this would be something like your cost to buy the item or your cost to make your item for your company. Okay. V of J here is the selling price of your item at your store here. So notice here this would be like the price to the consumer, if you will. Okay, depending on where your supposed company here is in your supply chain. Now notice what this is in terms of what's going on. Your cost at your warehouse, whatever it was, however that's calculated, then add in your shipping price is going to give you that selling price. Now, there's a bunch of assumptions going in here, and we're not going to make this scenario more complicated. So that's the only thing that we're going to use to do the correlation between these two prices, the selling price of the item at the store and the price of your item at the actual warehouse as well. Okay. Now what we're going to do is we're going to go ahead and look at this related formula to say that the cost of the item to go between the warehouses and stores is this C that we're given. We're going to make it to be the difference here of the selling price minus the price at the warehouse. Notice we just subtracted from both sides. And one of the things that we're going to do here is we're not going to overly fixate on what those prices actually are. We don't need to know what the prices actually are. All we need to know is essentially the relationship or the scale. So this common practice here is that you actually set the very first one of these prices, U1, to some arbitrary value. In our book, your author typically uses 10. Other books use other starting values that are convenient, like I've seen 1 before as well, but 10 is pretty common. So what we're going to do is we're always going to start with U1 equal 10, and then from there we're going to be able to solve for all of the other U's and V's. These selling prices are going to allow us to figure out what the new edge is going to be that we add into our solution. Now this here is our initial solution that we had back from step 1. So when we first calculate all of these U's and V's, we're literally just going to use that formula to sit up and try to find all of our U's and V's. Now notice we're not going to do this for every single cell. We're not going to run the I and the J indices through every row and column. We're only going to do this on our basic variables, and our basic variables in this tableau correspond specifically to the cells that have values in them. So in this particular case, our basic variables would be what? Well, we'd be looking at the cell that actually has something in it. So we would be looking at C11. Now C11 is the same as V1 minus U1. So if we go ahead and write that out, we have what C, now remember, C is not the value of the cell, C is the cost. So that's the label. So this would be 4 equals V1 minus U1. Then when we go over to the second cell, there's nothing there, so we move down to the second row. So this is C21. So this would be V1 minus U2. Notice your subscripts here are exactly flipped. Okay. So here, our cost on 2-1 is the 5, because that's row 2, column 1. And this would then be V1 minus U2. Notice the only thing we're swapping out after that arrow is the cost. Next one, cost in row and column 2. So this would be V2 minus U2. Put in the cost in that row 2, column 2. So that's 3 equals V2 minus U2. And then down here in row 3, there's nothing in column 1, but in column 2, we do have something. So this is C32, and this would be V2 minus U2. U3, excuse me, and this here, our cost in that little teeny tiny cell was trying to be an 8. That was trying to be an 8 right there, so this is going to be 8 equals V2 minus U3. So that's the setup. Now what did we do? We said that we are going to always set U1 to equal 10. We need that in order to solve for everything else. Notice we have a bunch of unknowns right here. A lot of them are repeated, and this being able to be repeated right here is because the underlying structure of each solution or underlying structure of each solution is actually a spanning tree. Okay? So having this underlying structure of a spanning tree means you're guaranteed to have duplicates. These aren't going to be 8 different variables. Instead, we're going to be ending up here with 1, 2, 3, 4, 5 different variables, and that's always going to be the case. It's one more than the number of equations you have. One more than the number of equations you have means you have to be given some starting piece of information, which we have right here, and now we'll be able to solve for everything else. Now, if U1 equals 10, notice we plug U1 equals 10 in right here. We then can solve for V1 by just moving everything to the other side. So we add 10 to the other side, so V1 equals 14. At this point, we now have what V1 equals, so we can solve for U2. Notice you won't always be able to go down top to bottom in the equations. You may have to jump around a little bit. Here, we're able to go to the next equation because we already know what V1 equals. Now, V1 right here is 14. So 5 equals 14 minus U2. Well, what subtracted from 14 equals 5? That looks like a 9. So if we do a quick double check of that, 14 minus 9 is 5, so yep, we're good. Next one down, we now have U2. We don't have V2, so we can solve for V2. Here, something minus 9 equals 3, so we can add 9 to both sides, which tells you V2 equals 12. And lastly, down here, we are going to be able to solve for U3. So here, 12 minus something equals 8. Well, 12 minus 4 equals 8. Okay? And that takes care of the values for your U's and your V's. Those are your selling prices. So then, of course, the question is, how do these selling prices help us add a new edge into our solution or create a new cell that needs to be a part of the solution? So here's what you do. You first of all look at all of your cells which correspond to your edges that are currently not in the solution. So these are called non-basic variables. They are all the blank cells. Okay. So you calculate the adjusted costs for each of these. This is specifically going to be the V minus U minus the cost that's in the label of that cell, and this corresponds to the amount that your edge I to j, so the amount that the edge that corresponds to the cell you're working on, is going to decrease your cost. You calculate all of those for all of your currently unused edges, in other words, your blank cells. You want to decrease or get the minimum cost possible, so once you calculate all of these values that are saying how much your total cost is going to decrease by, you grab the biggest one, and that's going to tell you which cell is going to be included in your new solution. So let's do it. So we go ahead and we have a copy of our current iteration of our tableau. We have already found the values of some of the U1s through we found actually all of the U's and V's, because 1, 2, 3, 4, 5 right there. And now we're going to calculate each of these new guys. Now, we're only going to look at these adjusted costs of the blank cells. In this example, we only have 2 blank cells, so we're looking in row 1, column 2. And this one here would correspond to V2 minus U1. Notice that's the same as the formula we had before, but here's the adjustment. We're going to minus the cost associated to that cell. So if we plug in this stuff, notice we already have the U's, the V's, and the cost. So V2 we said previously was 12, U1 was 10, and the label C1 and 2 we grabbed from the actual label on the cell, so that's given at the beginning of the problem. Okay. So in this one we'll go ahead and we'll get the value. The value will be negative, positive, or 0. All of those are perfectly fine answers. So 12 minus 10 is 2, minus additional 6 is negative 4. There's only one other blank cell, so we'll look at row 3, column 1. This one is going to be V1 minus U3 minus the label in that cell. So V1 was 14, U3 was 4, and the label in that cell was 6. Now this one here, 14 minus 4 is 10, minus 6 is 4. Now notice here we have two different things going on. And when we have these two different things going on, one's positive, one's negative. If you've got a 0, it means there's no change. So you could throw in that extra cell, or there's no need to because the current one is going to give you the same cost as the new one. In this particular case, notice there's two things. When you have a negative right here, that negative means you're going to decrease your total cost by a negative amount. In other words, you're going to increase your cost. So increases cost. So we definitely don't want to use that edge. This one here turns out to be your maximum value of the two and positive. Note, if the only values you get back are negative, don't choose any of them. You're done. You've already got the optimal tableau. You've got the optimal solution. Ditto if you've got zeros. The only time you're actually going to change your current solution is if you have positive values, and you always grab the maximum because this will give you the maximum decrease in your cost. Now, what does this tell you about the actual edges or the cells? This tells you that you want to add cell, which corresponds to the edge. That's this cell right here. So that corresponds to the cell 3, 1, or going between warehouse 3 and store 1. In other words, don't just use warehouses 1 and 2 to supply your first store. We want to throw in warehouse 3 there. So that's identifying which new edge we're going to incorporate.